Welcome to Extending ArcGIS Enterprise. My name is Shreyas Shinde. I'm the development lead for ArcGIS Enterprise. And I'm joined by Ashley Dipati.
Hi, I'm Ashley Dipati. I work in Esri Professional Services and work with customers on, among other things, extending ArcGIS Enterprise.
So whatever she says is the real thing, and I'm just trying to fill up the space and time. So let's get started. Okay, all right. So quick agenda, we'll cover basics and introduction. What is ArcGIS Enterprise? Some options for you as developers as to why you want to extend the ArcGIS Enterprise. Focus on Server Object Interceptors and Server Object Extensions. Touch a little upon the Enterprise SDK. This is a new SDK that was introduced at 10.6.1. And we'll cover some real-world patterns that we and Ashley has been seeing in our day-to-day work with working with customers as well. So hopefully that'll take 60 minutes. So how many of you are ArcObjects developers, are comfortable with ArcObjects? Okay, now I'm really worried. Okay, so this session does require you to know coding, that you should be familiar, and we will show you code, and some familiarity with ArcObjects or ArcObjects SDK is required to follow along. But we'll try to give you tips, and at the end of this session, we'll make sure that the content that we presented is available on GitHub. Source code is available on GitHub. Okay. So what is ArcGIS Enterprise? I think the plenary kind of covered quite a bit of what ArcGIS Enterprise is, but it is a very powerful mapping and analytics platform that's available, that runs in your own infrastructure. And it comes with a lot of configuration applications, configurable applications. It comes with a lot of tools. It comes with the new notebook server that allows you to write code and deploy in your infrastructure. But the way I think about it is it's also an extensible API. You can think of it as Lego blocks that lets you build your mission critical applications and mission critical workflows. So the heart of ArcGIS Enterprise is really these four components and some versions of these four components. There is the web adapter, which is basically just a software load balancer, followed by Portal for ArcGIS, which is a map-based content management system that comes with configurable templates and applications. It does your identity management and group-based sharing. And then you have the ArcGIS Server. It comes in various flavors, and we'll talk a little bit about what ArcGIS Server is. And of course, the ArcGIS Data Store, which is Esri's hosted data store. It's the data store where, if you just throw data at Enterprise, that's where it's going to get stored, right? So ArcGIS Enterprise is really a composition of all these components stitched together to give you that mapping and analytics platform. So the GIS server or ArcGIS server is really the geospatial brain behind ArcGIS Enterprise. It comes in a variety of flavors. There is the hosting server. You can add image services and an image license, and you can make it the image server as well. There's a geoanalytics server. There's a real-time server in terms of geo event server. And now at 10.7, you will have a new server called as the notebook server as well. And of course, there is a general purpose server. We call it the GIS server for your departmental use to mix, match content and publish content to your servers. So what a server does is basically expose web services. You can have mapping services, raster services, geocode services, geoprocessing services. But at the heart of it is that the brain really exposes web services, REST-based, callable web services, and SOAP callable web services. And as a publisher, what you do is you publish to the server. So you publish or create a service on a server. And once the service is published, that's where you get the web endpoints that you can call into from your applications or portal or other things. So as a publisher of the service or as an administrator, you can then manage the life cycle of the service. So you can say the service needs to be stopped or it needs a certain kind of pooling. That's what you can do as an owner or an administrator. So the first question that we get asked is, why should I extend? I really do not recommend converting an apple to an orange, but this is something that we get asked, right? Why do I need to extend? And here are some key rules. You extend when the out-of-the-box functionality is not adequate for your needs. You extend because you have custom business logic that needs to be deployed that captures your mission-critical or business-critical workflow. You extend because you have some security or compliance requirements that can't be met with the out-of-the-box software. And you extend because you want to integrate different systems together, and GIS is just one of your systems that is deployed in your organization. So if you really have information in different systems of record, and you want to bring it all together and make it available seamless to your GIS users, then you can integrate it with extending or writing code for your ArcGIS Enterprise. So as a developer, you really have four main options, and we'll spend a little bit of time on all of them. So the first is custom applications. So a custom application is an application that you build. Sometimes you can configure an application using configurable templates within ArcGIS, or you can use something like a web app builder to build a web application for your needs. You can even build thick clients like desktop applications, like using the runtime SDK or using some JavaScript API. But the idea here is that when you write a custom application, oftentimes the business logic is written and authored within the custom application, right? That's one way to extend. The other way to extend is geoprocessing services. I think most of you must be familiar with geoprocessing services. They are the premier analytical services that the server has. You can publish your Python scripts or code as web tools or geoprocessing services, and the server will host them and give you an asynchronous API to call those tasks. Now, this is really the bread and butter of most GIS analysts. They can author scripts in desktop. You can publish them to the server so that more users, more consumers of that service can exist in your organization. Anybody published a geoprocessing service before? Right. So as you all know, you can write them in Java, you can write them in .NET, but the most popular language is Python. You typically write them in Python and expose it as a tool. And it's really great because you have access to the Python API, and it's an asynchronous API. So you submit a job and you wait for the job to complete, and then you can request the result, right? That's the contract with the geoprocessing service. But we are going to spend today's workshop on the two other options, which is Server Object Interceptors and Server Object Extensions. So let's get into Server Object Interceptors. Anybody see today's plenary? Anybody remember today's plenary? Do you guys remember a HIPAA scenario that we portrayed for compliance reasons? And you are still here, so that's a compliment. But Server Object Interceptors is the technology that was used to achieve that level of compliance. And today I'm going to spend a little more time and show you actually the code and the deployment that makes it possible. On the plenary stage, it's like 3 minutes and it's all done, but we have a little more time in a workshop. So the most popular use cases for Server Object Interceptors are security, access control, auditing, log recording, notifications. These are common workflows that we hear when these are Server Object Interceptor is a common solution proposed when users ask us that I have a security requirement, or I have an access control requirement, or I need additional logging or additional record keeping for requests that have been made to my server. So at its heart, it's really a plugin architecture that allows you, the developers, the ability to filter requests and responses as they flow between the client and the server. So let me show you what this looks like through a little bit of animation. So I have a GIS server, and to it, I've deployed a service, my map service, for example. And map services run in these processes called ArcSoc. Anybody know what these ArcSoc are? So they stand for Arc Server Object Container. It's a process boundary in which the code actually is created and constructed and lives there. So when you deploy one or more interceptors, you can actually form a chain of these interceptors. I'll give you a little demo of that. And it sits like a chain before, in front of your map services. And then you have the web handlers, the typical REST API handlers and the SOAP API handlers that receive all requests from the clients. And of course, on the left, sitting outside your load balancers are your web clients. So when a request is made by an application, it typically arrives at the web handler, REST API or SOAP API handlers. And from the web handlers, it's routed to an appropriate ArcSoc process. There are some load balancing rules that are observed when the web handler chooses which ArcSoc process to route to. But it happens, and the first request that lands, in this case, will land on your interceptor code. Now, within your code, you can decide what happens to this request. If the request does not meet your operational requirements, you can terminate the request, return a response back to the client. You can rewrite the request and let it go through. So basically, simply delegate it, right? So it's a classic servlet filter pattern that, if you are Java developers or if you've written ISAPI filters, it's like a filter pattern that is available. You decide, your code decides what happens to the request. You can rewrite it or you can basically return it. So in this case, my first SOI did some sort of an access control, right? Some security check. My second SOI probably enriches the request or connects to an external source and does something more with the request. And it lets it continue and go to the map service. The map service does its magic, and it will go connect to the database. If it's a draw request, it will draw your map. If it's a query request, it will go and query your database and return the result back. But the result again goes back, through the same pipeline. You, as developers, have the option to deal with the response as it goes through the system and back to the client. So it's really a filter that you deploy between the client and the server. But what I think the takeaway point here is that because you are actually sitting between the client and the map services API, you as developers really cannot change the API in any way. So you have to work within the map services API, which is documented and available. You can rewrite the query, rewrite the request as it goes to the map service. You can rewrite the responses as it goes to your clients. But if you want the applications to continue to work, then you cannot rewrite or mess with the API, right? So what's the benefit? Well, the benefit is that there is no need to rewrite or build any custom web applications to deal with this interception logic, right? It just works as if the clients just think that they are talking to a map service or an image service in that case, okay? So let me show you a quick demo, which is going to be a sort of an elaboration of what I presented at the plenary today. Okay, so I have here the same Inland Empire healthcare system. By the way, this system does not exist. I made it up. So do not try to subscribe to this healthcare system. It's not going to do you any good. So I am logged in here as a GIS analyst. As a GIS analyst on this side, on the left pane. And as a GIS analyst, I have access to this patients and hospitals feature layer. So let me bring it into a new map. Okay. Now on the right tab, it's again a Chrome incognito mode. I am logged in as a nurse administrator. Okay. And I'll set up the story as I go along, but let me log in. So here you have two accounts. Can you guys see this okay? I'm sorry, the blue really is horrible. So I have two accounts that are actually viewing the same feature service, right? However, this is a healthcare database that we are talking about. These are patient records, the blue points are patient records, and we have hospital data. These are the two feature layers in my map. Now, as a GIS analyst, to meet with the HIPAA compliance, I am not authorized to access additional patient attributes. So if I were to query the attributes of this patient, you can see that I only have access to one attribute, that's patient ID, right? And that's expected. Now, I will do the same as a nurse administrator. It's the exact same service, but I see more attributes. This is possible because I have deployed a Server Object Interceptor that's intercepting requests to these feature services. And it's rewriting the responses based on who is logged in, based on their roles, right? So as I said, interceptors are great because I did not have to write any custom applications. This is an ordinary map viewer. It does not even know that there is some sort of an interception code that's going on. There is custom code that's been executed. Now, how did I build this? Well, the first question that probably should come to your mind is, well, what's the big idea? We could do this in a feature layer views. Anybody heard about this concept before, feature layer views? It's a new concept got introduced at 10.6 in online and 10.6.1 and 10.7 in enterprise, where you can create various views on a feature layer, and a view can be defined as an attribute filtering or spatial filtering. But the reason feature layer views don't work in our case is because the system of record for a healthcare system is not a GIS. The patient records are actually not stored within my GIS. They are actually stored in an electronic medical records database. So feature layer views are not applicable because the data actually is not there in my GIS, right? So views are applicable or can be used only when your source of authoritative data is your GIS. In this case, the data is coming from somewhere else. So what really the SOI is doing is it's enriching the feature layer and bringing additional attributes and data from another source. And what is that source? Well, it's my homegrown electronic medical records database. Okay, so I have a simple table to simulate that if you have an EMR or some sort of an external system where you have other business data, your SOI can bring that into your feature layers. So this is my patient and provider data. Trust me, this is all made up. If you read it, you will know that this is made up. Okay. I have a nice little Java application that can generate data for you if you are interested. But these are tables that I created, and the data is all made up to simulate that there is an electronic medical records database. It's an external system that you can call into. So let me show you the code that powers this. So the first things that you do when you are tasked with writing an SOE or an SOI is you install the appropriate SDK. So I have here the Enterprise SDK and the ArcObjects SDK for Java, right? So I have Java bindings and I can write Java code. Typically, what I do is I use the Eclipse plugins that are available within the SDK, and I start my project using the Eclipse plugins. They are a nice visual way to get started, and that's the most recommended way to get started. Yes, sir.
Do you use IntelliJ?
Actually, I am using IntelliJ, so that's where I'm coming back. So, but my IDE of choice is really IntelliJ. So what I typically do is I use the Eclipse plugin and create an empty project. And I zip up that project, and then I open it up in my favorite IDE, that's IntelliJ. Trick works. I'll show you some more tricks. So the Eclipse plugin basically creates the scaffolding, right? All the boilerplate code and templates that you need. And once you have that, you just import it into an IntelliJ or any other IDE that you care about. Any NetBeans fans here? Okay. Well, what I'm about to show you also works for Visual Studio, right? So the idea exists, but very rarely I've seen anybody use anything other than Visual Studio for C# development. So I've written a Java class, and I have to annotate it as an interceptor. You can see, you can give it a descriptor or name. You have to annotate it as an interceptor, and you say, this interception works on a map service. And that Java class has to implement these interfaces. This is a prerequisite for a Server Object Interceptor. Server Object Extension, the ability to handle REST, Web, REST Handler 2, and REST Request Handler. The reason you have to implement all these interfaces is because Map Server implements all these interfaces, right? And because you are masquerading or really filtering requests that a map server receives, you must implement all these interfaces, right? So when you typically start, the way I do it is, I'll come back to this initialization function, but basically the plugin creates a boilerplate code for all the functions. It stubs out all the functions for you, right? And then you slowly open up each function by writing your business logic. Okay. So when your object is created as an interceptor, this initialize or init method is invoked. And in that, I am creating a connection to my EMR database, just a business object that connects to EMR. And most external systems have some sort of an API that you can call into, either RESTful or you have Java bindings for it. Now I start implementing my core business logic. So this is my handle REST request method. So as the name suggests, this method will get invoked every time a map service request is made, a REST map service request is made to your map, or a feature layer request is made. That's RESTful. So you can see that the payload looks very much like a REST request. It has capabilities, it has a resource name, operation name, input, output, and a bunch of properties. So here what I'm trying to do is, I really want to rewrite the responses as they go out to the client, because that's what I'm doing. I'm enriching in this case. So I let the request, let the map server handle the response request first. This is, I get a response, simply delegate to a map server and get back a response first. Okay? That response is what I want to rewrite in my code. That's my interceptor. And that is a response which I'm trying to rewrite. So if it was a query request or a layers request, then I'm enriching it or rewriting that response. And here is that response. So I have the original response that the map server sent. It typically just sent the patient ID in our case, because that's the only thing that's there in the database. So I do a little bit of access control and I say, well, if the logged in user is a GIS analyst, don't enrich it, because the GIS analyst is not authorized for any more attributes. If it's not a GIS analyst, that's where the rest of the code will start executing. Well, from the query response, you get fields and you start inserting additional fields. So here I'm inserting a first name, last name, sex, next appointment, and next appointment location, right? Just some 5 fields that I could get. Now, this is where the sort of schema is. These are the additional fields, and now you populate the values for each field, right? So it's almost like you're creating a table header. And then for each record that you received in your response, so for every feature, You basically make a query and say, hey, from my external system, can I join this particular ID of the patient? Can I get more information for that patient from my external system? And this is where I'm using the EMR database and getting a patient for that patient ID that I'm iterating over. Okay. And then I find additional attributes to populate. I insert those values, and so this is where I set the attributes in addition to what I already got as a patient ID from the map service. And at the end, I'm writing a log record, right? It's always great to log, right? So I'm writing a record back to the EMR in this case, and this basically rewrites the response as it goes back to the client. Does that make sense? Approach make sense? Now, sometimes you may want to rewrite the request itself. And the question could be, well, why would you want to rewrite the request? Well, let's say that I, as a user, could access business data for the nationwide Target stores or Walmart stores, whatever it is, right? But I, as a manager of a particular store in Southern California, in Palm Springs, I shouldn't have access to any more information. Well, in that case, you can rewrite the query and say, just this attribute and just this extent. And you can send that to the map service instead of giving the full extent and all the attributes, right? And it's a very similar pattern that you can follow to get that going. And so I like IntelliJ and I like automation. So what I have done is I've converted this to a Maven project. And so basically I can build it like this. So it will build my project and it runs my unit tests. Always good to write unit tests, right? And these unit tests right now are integrated. So there are about four tests, and you can see that with no failures. So enterprise grade software, build processes. It's it's Maven. I can put it into a CI/CD, and there is unit tests that can work with it. Make sense? So what I showed you sort of applies to Visual Studio and .NET development as well. It's not much different than that. I'm just using Java IDEs and Java tools to build it, but the pattern still applies. Okay. Switching back to slides. So let's switch to server object extensions. So unlike server object interceptors, which does not change the API of a map or a feature or an image service, server object extensions are altogether custom server-side code with their own custom APIs. And you would typically write them because you have certain editing workflows that can't be met with out-of-the-box editing solutions. For example, you might have a topology requirement that says upon each edit of a geometry that you must be topologically sound, right? So you need to enforce additional constraints before actually accepting those edits. Or you may want to do data processing. The data comes in, you may want to further enrich it, augment it before it goes back into the database. You may want to do additional QA/QC before it goes back into the database. Another use case that we've seen is network analysis, where you want to implement some sort of a custom impedance function or custom routing or solving problems that the out-of-the-box solvers do not allow you to use directly. Or you may want to implement your own image functions or a raster function for your image services. So the out-of-the-box image server has many functions that are available to you. But sometimes you might want to just build your own NDVI for a particular reason, or pan sharpening, or a certain raster function that's not available out of the box that's relevant to your business. You may want to use server object extensions. So let's look at the architecture again for server object extension. So I still have the GIS server, and I have my map and image services. And they typically have a well-defined API, and you have applications that consume that well-defined API. Now, when you build and deploy your SOE file, it attaches itself to the map service or the image service. But that SOE exposes a new custom API. You as developers are in charge of that API. But because it's a custom API, you really need to build custom applications that take advantage of that API, right? So you understand the difference between interceptors now and extensions, wherein one sort of kept the old map services contract. Here, server object extensions, it's a free form, like you are in control of the code as well as the implementation. But then you have to write custom applications that can take advantage of those implementations, right? So let me jump to a quick demo here as well. Okay, so I'll set up the scenario as follows. Whoa, okay. So I have a map that contains polygons, and for each polygon, there is a type of forest that represents that polygon, right? So I'm a lumber or a logging company that wants to know, for a particular area, what's the different kind of vegetation that's available in that buffered area, so that I can apply or dispatch a certain kind of logging or lumber operations. So to do that, I have a map and I have some data as vector data. So let me first show you the custom application, and then I'll walk you backwards. So here is my custom application. It's a simple JavaScript application, okay? And you set a buffer and you click a point on the map, and it gives you these meters for the different kinds of vegetation under that buffer, okay? So you might want to think about some insurance cases or some sort of a resource allocation case where, so the idea here is that the buffer needs to really proportion or proportion the area under the curve for each vegetation and clip it and tell you for each vegetation what's the area under the curve, right? This can't be done, this can be done. One way to achieve this is to build a custom application purely client-side. Talk to the map services or a feature layer data, get the data on the client side, do your own clipping, and then do the apportionment, right? You can do that. The challenge there is, the only way you can do this is if you fetch all the data to the client side, right? Now it depends upon the kind of data and the volume of data you are talking about. So your application will have to fetch all the data and then do the business logic on the client side. Another way is to implement it as a server object extension. And why is this a good idea? And it's a good idea because your code runs on the server, sits close to your database, and can actually do the computation much faster than fetching the data onto the client side, right? Think about caching that you can do on the server side as well. You can cache certain extents, you can cache certain predefined queries for faster performance rather than every user with an application trying to do it on the client side. So I've authored that server object extension, and I think something that I did not show you before is once you've authored one of these extensions, you build it out, it builds into a zip file with a .soe extension. That contains your compiled code, contains configurations, and you simply upload it to your server manager. I've already done that in this case. Okay. This process simply registers your code, your extension with the server, and it distributes it on every node in the cluster. So you don't have to do it. Now, one more thing that needs to be done is on a given map service, you actually have to enable this as an extension. And you can do that by going into that map service. So this is my land cover map service. And you can see that I have enabled this .NET Spatial Query REST SOE. Okay. So what does this look like from a REST API perspective? So here is my land cover map service, right? It looks like this, right? Now, if I use this REST services directory and browse this API, you can see that at the bottom, there is a supported extensions label. So this is my spatial query REST. This is my extension that I've built. And I am in control of creating the hierarchy of resources underneath this API that makes sense, that makes business sense for my organization or for my users. So in this case, I have an operation called spatial query, and it takes in a location, the XY location on the geometry, and a buffer distance, and it gives me back a response that contains all the geometries along with the proportioned vegetation for each. Okay? So how did I do this? Well, I wrote the code for this in Visual Studio. I didn't want to bias Java versus Visual Studio. So this is for all the .NET developers out there. So I have a vegetation calculator as my class. You can start typically with a template, and that's what I would recommend. That we ship, the SDK comes with a variety of samples and templates, and you can simply launch one of them and then rewrite it as needed. So here, because it's a custom extension, I am free to choose any of the interfaces, the 4 interfaces that I mentioned before. So here I have an iServer object extension and iREST request handler. I only want to make my extension available via REST API, not via SOAP. That's all I need to implement. So the first thing that I do is create schema. This is the operation that gets invoked when we are trying to discover what is the REST API that you want to expose. So here you can define that you have an operation, calculate area or spatial query. It takes it's 2 attributes, location and distance, and it's JSON. Supports JSON as the format type. And then this operation is given a function basically that says this is the query handler for that operation, right? And so this is where the meat of that implementation is, my spatial query operation. Basically, it takes the input geometry and converts it into a point object. And then it just does a query point, basically. This is all custom code. So I'll show you what query point looks like. So the first thing that it does is creates a buffer. Because the user has clicked a point, you need to create a buffer. It does the spatial query, sends it to the database, and gets the result that meets that spatial query. It loops through all the features and clips them to the geometry of that buffer, right? Because you're trying to clip everything, all the different kinds of vegetation to that buffered clip. And then it basically just runs it does the aggregated area for each type of vegetation. And then return the result as a JSON object back to the client. Make sense? So I am in control of the API, I am in control of the code, and I have to write the custom application to consume this API and code. Okay, let's get back to our, of course, this builds very similar. You can just build it and it'll build into that SOE file that you will upload and all that good stuff. Yes, sir.
Is deploying the SOI the same process?
Yes, absolutely, absolutely. So whether you write an SOI or an SOE, you still get an application zip file with a .SOE extension. We were not trying to be very creative at that point. And you follow the same process, which is you take the zip file, you upload it, it'll farm it out to all the nodes in your cluster, and then you activate it on your service. That follow. Yes, sir.
Any way to debug in Visual Studio, for instance?
You read my script. Yes, actually debugging capabilities are available for both Visual Studio and Java, and I'll show you that in a little bit. So the first thing that I want to show you is how do you debug in, sorry, let me bring my, how are we doing on time?
20 minutes.
Okay. Okay, since you've been such a great audience, I'm compelled to share this with you. So the first thing that you need to know as a developer or a debugger is that this is my server. It's running on this machine, and you can see a bunch of ArcSoc processes. Fair? Now, Visual Studio basically allows you to attach to one of these processes. So you could just say Visual Studio attach to process, and you can select all the processes in that list. And when the code hits, it's going to hit your breakpoint because you're attached to all the processes, right? A smarter way to do this is to look at the command line argument for these processes. Because we print out the name for each service and what the ArcSoc corresponds to on the command line argument. So can you guys see this thing, this -t service property? It's not very visible. Let's see. Let me. Does anybody know if you can expand the font of Task Manager? I don't think such a person exists. I am not very good at using the magnifier. So let me see if I save this on desktop. Is that better? Low tech? Okay, here you go. So you guys see this property, this thing here? Right? So we basically print out the name of each service for that ArcSoc process. So rather than attach all processes, you can simply attach it to just the process that you care about. So in my case, it would be this guy. Right? Land cover. So if you attach it to this process, when the code arrives on your extension, it'll hit the breakpoint. And I promise that it works.
What if you mess up and you put it on all of them?
Well, you just restart the server then. Well, it's oftentimes, well, highly recommend not to debug in production. I think it reminds me of a t-shirt my colleague wore one day, I think a few weeks ago. It says, "I never debug my code, and when I do it in production." I'm like, that's a gutsy move, right? So not recommended to do it in production, because Visual Studio does something very interesting sometimes. If you have elevated privileges, it even has the ability to terminate your processes. So not recommended. Okay, not recommend that you do this in production. The other thing that I wanted to show you is the server manager.
Could you do the same thing in IntelliJ? Attach this to
Yes. So IntelliJ is a little interesting because Visual Studio as a native application can connect natively to Windows processes. For IntelliJ, it being a Java application, you need to do a few extra steps, and that's where I'm getting to. So on this page, when you saw that I could add an extension, you see debug settings. So you click here and you say enable debugging of extensions, and you can give it a port range. So I typically use something like 10,099. to 10,000, 1,150. So I give it a port range of a few ports, and then I save. And when I restart that service, it'll have the Eclipse Java debugging properties on it on that port. So all you have to do is go back to your IntelliJ and simply do a remote attachment to that process on that port. Java debuggers, you can like following this pattern. So I can basically do a remote, sorry, let me show you a remote. Sorry, so this is what I want to show. Edit configurations. This is my IntelliJ IDE for Java and Java debugging. I can add a remote, and it basically gets this thing, right? So this is where I would put the property associated, the port number associated with that ArcSoc process, and simply attach it. Does it make sense for Java developers? Like the way you classically debug in production, right? This is what we do. I didn't say that. Okay, all right. So the simple process is install the SDK, start with the templates. I have not come across any brave soul who starts directly with the IntelliJ and code, starts writing code. For SOEs, I would highly recommend that you start with templates, okay? You add your logic and you build, and it builds a .SOE file. You upload it via manager. You configure it as an extension or an interceptor on your service, and then you debug, right? What I have found most effective, like the most effective teams or effective developers automate this process. Registering extensions to Server Manager is a REST API, which you can automate. You don't have to do it manually. Manager is powered by an admin REST API, so you can just call the REST API to register it. Likewise, you can call a REST API to configure the extension on your service. It's well documented REST APIs. So basically, you can do this process as a script. So at the end of, or even in your Maven build or your Visual Studio post-build processes, where you take the build output, you stop your server, or you undeploy your old extension, upload your new one, and then enable it on your service. It's the fastest way to spin and be productive with in a coding environment for extensions. Okay.
Do you have example scripts of that automation?
I don't, but I can point you to the REST API, and maybe after the talk I can point you to the REST API that makes that possible. Okay. So the last thing that I want to share is Enterprise SDK. So you can publish from ArcMap, map and map feature services, image services, and you can publish from Pro. So we have one SDK for services published from ArcMap called as the ArcObjects SDK, Java and .NET. But we have another SDK called as the Enterprise SDK that lets you write extensions in a very similar fashion for services that have been published via Pro. They are both available in Java and .NET. You can use SOEs and SOIs. The API is very similar to the ArcObjects API, but it's not binary compatible, which means you can't simply take your SOE that you've authored for your ArcMap published services and attach them to a Pro published services. You have to recompile and rewrite some portions of your code. There is a good migration topic in the help doc that says if you have an ArcObjects SOE or an SOI and you've written it this fashion, how can you migrate it to an enterprise SDK, right? Why did we build this? We built this because we are seeing an increased usage of ArcGIS Pro and Pro-based map and image services. And we wanted to have functional parity for ArcMap-based services in terms of SOEs and SOIs. However, there is some ArcObjects, they are not binary compatible. Pro ArcObjects are not binary compatible with ArcObjects, so hence the new SDK. And the extensions can coexist, which means You can have a service from ArcMap. You can have your same code, your code as attached to that ArcMap service, and then you can do the same for Pro as well. So I'm going to switch to some patterns that we are seeing in the real world. And Ashley, do you want to start with this one?
Sure. All right, thank you. Thanks, Shreyas. So this real-world example is a customer that I worked with recently who is a service provider. And they have their data that they have acquired and spent a lot of time working on and acquiring this data and maintaining that data. And they provide that to their users for a fee. So the use case that we worked through with them was an advanced audit tracking to be able to track which users are using their services and what the users are doing with those services. A very similar use case, you could do the same thing for advanced security reasons if you needed to do audits for HIPAA compliance or anything else like that. So the big question here is that the end users of your map and feature services use them without you really knowing or controlling exactly what they're doing with them. Your end users may be using them in Pro, in ArcMap, they may be using them in an application, web app builder, or they may be building their own custom applications that access them. And they can be doing a variety of things with them. They can be viewing the content. They can be running analysis on these and creating new data as an output of that. And they can even be downloading and exporting your data to their hard drive and using that for other purposes. And the big thing here for this particular user is that viewing data and downloading data have very different business values for the customers who are using that data. So in order to do that, in order to be able to track that information, to understand it, we need to be able to log very fine-grained information about the user interactions. Why use an SOI here? If you turn on fine logging in ArcGIS Server, you can actually get quite a bit of information about the users that are using it, specifically on query requests and in your feature service requests. But you can't get that same level of information in a map server request. So the pattern that we worked with this customer was in order to be able to understand exactly which features the users were getting from an export map request was to basically log the request that the users are submitting. The reason for that is we need to be able to redo that request to understand what features are in that request. So my diagram here, which may or may not make sense to you, shows that the SOI is actually, for each request that's coming in, the SOI is logging that to a request log. And then at a later time, we have a batch script, which is reading in all of those requests and then submitting those as query requests to the map server. And in that way, we can get all of the individual feature information. We can understand what that user was drawing on the map at that time. And then we can save that information somewhere for our tracking purposes. The important thing here, and important consideration here, is you don't want to be doing this while the users are using it. You want to be doing this during off hours because it has the ability to impact your server load. So now that we have all of this very fine-grained information about what exactly our users are doing with the services, the question is, how can we determine what workflows those users are doing? Are they downloading this data or are they using it? And there's not an out-of-the-box way to do this today. And I don't think that there is an out-of-the-box way to definitively differentiate this. But the approach that we settled on with this customer was using heuristics on the request and the response objects themselves to make a probable, a guess, but a pretty good guess as to what the end users are doing with that information. So the SOI that we just discussed logged all of the advanced information, and then we used heuristics after the fact to determine whether or not they were doing a download or a viewing request. I put a table of the heuristics here. The most important ones are if the request includes geometry, the number of features, how many fields are there, and then there are some special flags that occur that Pro and Portal use if they're only going to be drawing the information. You can rule out exporting if those two flags are there. There are some caveats with this approach. Obviously, anyone who has a custom solution can write whatever the heck they want, and they can. So if they are writing some scripts to scrape your data, there's not much a heuristic won't help you with that. And of course, there is the caveat that the heuristics should be validated with new releases because these are not like published official heuristics for determining what users are doing with your data. But it was a very interesting use case, and so we wanted to share that with you.
I guess just to extrapolate that, you could implement some sort of a throttling as well within your interceptors. If you are a service provider providing map and feature services to your end customers, based on how frequently they are requesting information, you could build some throttling.
Yeah, you could definitely do that.
One more pattern, and we jumped a few slides. So one more pattern that we wanted to highlight was pattern for SOEs that take a long time to do their work. So we had a customer who wrote an SOE, and the SOE had two operations on it. There was a sync operation and an async operation. So the same work could be done in a blocking call, and all these APIs that you build on your SOEs are typically blocking calls. But they were doing something really expensive within their SOEs for that operation. So typically what happens is if you do work for more than 60 seconds and you do not respond back to your client, your load balancer will terminate that request, right? This is the way AWS ELB works. They have a 60-second by default, which you can configure. But anything that takes any amount of time over 1 minute is not a good idea. You don't want to keep the client waiting. So here is a pattern where you do want to expose an asynchronous API to your client in an SOE. And so the way you would do it is you implement your core logic as a GP service rather than an SOE. And you attach an SOE to your map service, but the SOE can work in a dual mode. It can either if it's an asynchronous call, it can basically submit that request to a GP service, get a job ID back, and return it back to the client. Now, when the client comes back and says, hey, are you done with my request? You can continue to poll the GP service because the GP service is asynchronous and allows you and gives you these primitives of get status, get result, to allow you as the SOE developer an asynchronous API to your client. That way, the clients don't block forever for you to do your expensive operations, and there is efficient use of resources on your server as well as on the client side. And this is eating our own dog food as well. If you have ever used, create replica or sync replica on feature services, this is how they are implemented. The feature service is actually an SOE on a map service. And there is a GP service called as the sync service on your server. That does the exact work of exporting the SQLite or the JSON database and actually doing the work. And the feature service in that case is just a facade that gives you the coherent feature services API, but behind the scenes it's simply calling the GP service. Okay. So with that, I think we are almost out of time, but we always have more content. So the content will be available in the slides so that you can reference it, refer to it at a later time. So a few things to touch up on was migration. One question that we get is, I have ArcMap based services. I have written all this SOE and SOI for ArcMap. Now, people in my organization are publishing Pro-based services. How do I migrate my SOEs and SOIs to Pro-based services as well? There is a migration pattern that you can follow, and I have a link to the doc that clearly outlines the steps. Okay. Troubleshooting, we covered. The best way is logging. When you are in production, the only way to actually get information is by logging. Unlike, please do not debug or set breakpoints in code in production. So logging is your friend, and when you're writing custom code on an interceptor or an extension, we recommend that you log enough and adequate to give you. And the best part about extensions and interceptors is whatever logs you generate go into the server logs and can be queried by Server Manager and the admin API. So it's not like you need a altogether new logging system to do this. So it's easy, use it. Make sure that you package dependencies correctly. This is one issue that we see people, especially Java developers. There are some jars that your code references, and it's not packaged well. And so when the SOE loads, it basically just falls apart, and you get an error, an ugly-looking error that says class factory could not supply the required class. I have no idea what it means, but that's what you get. And the logging is your friend at that point. Make sure that you are aware of your startup time. So remember, in the init function, I'm connecting to the database. Like if you're doing a whole bunch of jobs before you start, then your service is going to time out. So that needs to be really short and sweet. Okay. So quick connections, not overly computationally intensive work in the init method. We touched upon debugging. There are multiple ways, .NET as well as Java, and instructions are in the slide to help you achieve that. So final words, start with the samples and templates. They are a great starting point for your custom SOEs or SOIs. Automate as much as possible. This will really save you valuable time when you're doing frequent delivery, frequent updates. Use GP services for long-running tasks, and we sort of highlighted that pattern today. Don't change the API in an SOI. So it's a map service API. You have to abide by it. If you drop key attributes or key fields within the API, your applications are not going to work. So as an SOI, you have to work within the realms or within the API of your map feature image services. As an SOE, you can do whatever you want. If you are implementing some sort of security or access control, you must be careful. There are many gateways or entry points into your code, and you make sure that you've patched all of them before you can assure and say, this is a good SOE, security SOE. Okay. At this point, there is no SOI for hosted feature services. They are run in a different technology right now. They run as Java based inside the web server. So the ArcSoc based pattern that we showed today does not apply to hosted SOIs, but this is something that we are working on, and hopefully we would be able to build it in a future release. And lastly, if you are doing expensive operations in code and your payload sizes are large, you may want to bump up the heap size, which is what your ArcSoc, it's a Java process really. You may want to bump up heap size, and there is documentation that tells you why you need to do it and how you need to do it. Okay. And with that, thank you so much for being such a patient audience. I think I had a great time presenting. Ashley, I hope it was good for you as well. And more importantly, I hope you took something that was valuable to your organization and for your workflows. So thank you very much. And please fill out the session surveys. It will really help us fine-tune what you need for our next offering. Thank you very much, and have a pleasant evening.